Hello everyone. In this video, we will be discussing on leveraging Alchemy for dApp development on Rootstock. So first we will be seeing what is Rootstock. So Rootstock is a smart platform that is built on top of Bitcoin blockchain. It aims to extend Bitcoin's functionality by enabling the execution of smart contract. Similar to what Ethereum offers, Rootstock achieves this by utilizing a two-way peg mechanism that allows Bitcoin to converted into RSK tokens, RBTC, and vice versa. This integration allows developers to create decentralized applications dApps that benefit from Bitcoin security while leveraging the flexibility of smart contracts. Now we will be looking into some of the key features of Rootstock. So first one is compatibility with Ethereum, which means Rootstock is designed to be compatible with Ethereum's tooling and smart contract standards, allowing developers to easily port their Ethereum dApps to the Rootstock network. Second is security. So by leveraging the Bitcoin network security, Rootstock provides a robust environment for executing the smart contracts. The next one is the scalability. Rootstock aims to improve the transaction throughout and reduce fees compared to Ethereum network, making it more attractive option for developers and users alike. Now we will be seeing what is Alchemy. So Alchemy is a powerful blockchain development platform that provides developers with the tools and infrastructure needed to build and scale decentralized application. It offers a suite of APIs, developer tools, and analytics that simplify the process of interacting with blockchain networks. Alchemy is designed to enhance the developer experience by providing reliable and efficient access to blockchain data and services. API, which means Alchemy API allows developer to easily interact with various blockchain networks, including Ethereum and Rootstock, enabling them to make API call for transactions, smart contract interactions, and many more. Real-time analytics. So Alchemy provides a real-time monitoring and analytics tool that helps developer track the performance of their dApps, understand user behavior, and optimize their applications. The next one would be developer friendly SDKs. So Alchemy supports multiple programming languages and like React, React Native, JavaScript, Golang, Python, and many more. So it has like multiple language and SDKs, making it accessible for developers with different preferences and expertise level. The next key feature would be enhanced performance. So Alchemy offers feature like reinforced transactions, which basically improve the speed and reliability of on-chain transaction. So we will now be getting started with the Alchemy. So first we need to sign in. So here I will be signing it using Google. So like I will be selecting as personal. So I will be naming it as Rootstock first project. We will be selecting as DeFi as an option. So which chains are you building on? So we will be simply selecting as Rootstock. Also we can select multiple chains. So we will be selecting Ethereum, Polygon PS, Arbitrum, Bitcoin, Avalanche. So now we successfully got signed up into the Alchemy platform. So now we will be on to the dashboard. So first we will create a new project. Now we will be creating first new app. We will be naming it as Rootstock. We will be writing description as Rootstock. Now we need to select the chain. So here we will be searching on Rootstock. So Alchemy supports to the Rootstock both testnet and mainnet. So now we have selected, just we need to click on the next button. So here we will be using Node API. So we will just unselect the token API. So now just the Node API is selected. Just need to simply click on the create app. So yeah, here the Alchemy gives us the initial setup where they are providing with us the API key, the network URL. Also they have various methods declared like get block number, which gives us the latest block. They also have Alchemy get asset transfer, which gives us the transaction string from an address. Also they have Alchemy get token balance method, which gives us the token balance from an address. Here we can select multiple languages. So by default it is JavaScript. So we can select its TypeScript. You can see the code from the right side is getting changed. It is basically the initial code setup that we need to integrate it into our main code base. So now we will see how to use Alchemy and create our first dApp. So we will be creating a folder into our local. We will be naming it as Rootstock. So we need to open it using an ID. So we will be using cursor as an ID. So first we need to add the package.json. Now we will be initializing hard hat. We need to initialize the hard hat. So we need to select JavaScript as we are using the JavaScript language. So we will be setting the initial project route as given by default. Also we need to add the git ignore file. Also we need to install the dependencies. So yeah, as you can see, the basic initialization of the hard hat has been successfully implemented. Now they are just installing the dependencies from the package.json until we will just simply create an env file which we will be needing. Here we will be needing the API key. We can just simply name it as Alchemy API key. As we will be using testnet, so we just need to select the testnet and copy the API key. Now we will be adding the private key. So now we will be creating a solidity file into the contract folder. We will be deleting this. So here we will be writing the smart contract needed for our dApp, adding the license. We need to select the solidity version. Here we will be using 8.0, 0.8.0. We need to declare the contract as we have named the file as message board. So we will simply write the message board over here. Now we will be creating this struct which is a custom data type, naming it as message, into which we will be declaring address with name as author, string with name content, uint 256 with name timestamp, and last uint 250. Now we will be declaring the message array. Now we will be writing the events. So in total there would be 2 events. So we will be writing it step by step. First one would be message posted, into which we will be passing address indexed content stamp. The second event would be message typed. Here also we will be passing address index typer, 56 indexed message ID. Last one would be amount. Now we will be writing the function which would be post message, into which we will be passing arguments as content. Here we will be declaring the function as public, which means we can access it anywhere into the contract. Here we will be passing message into which we will be passing next one we will be passing as content, and the last we will be passing timestamp. Also we need to pass dips. The initial would be 0. We would be emitting it, which emits the cold message. Here we will be passing message.sender, content, and the block with the timestamp. Now we'll be writing the another function needed, which is simply the tip message. Here we will be passing arguments as message ID, which would be public. We will be declaring it as a variable. Here we will be checking with the condition into require the value should be greater than 0, message.value greater than 0, tip amount here we can write as tip amount must be greater than 0. Now simply message storage, message ID, and we should add the value of tip into it, which can be done using message.value. Payable message.author. We need to transfer the value by simply doing message transfer value. Now we will be just writing the last function required, which will be like get messages. Here we will be not passing any kind of parameters. We will be keeping the function as public. View returns message array, which will be simply returning the messages. So yeah, this is our final contract. So the message board contract is a simple decentralized application built on the Ethereum blockchain that allows user to post messages and tip other user for their messages. So now we will be discussing the components and functionalities. So first is like struct. We named it as message. So this struct represent a message posted on the message board, which basically contains author. Author is basically the address of the user who posted the message, the content, the actual content of the message, the timestamp, the time when the message was posted, and the last one is tips, the amount of ether in Y that has been tipped to the messages. The next one is the state variable messages, which is an array that stores all the messages posted on the board. Each message in an instance of the message struct So the next one is the event named message posted. So this event is emitted when a new message is posted. It includes the author addresses, the content of the message, and the timestamp. The next event is the message tipped. So this event is emitted when a message is tipped, which basically includes the address of the tipper, the ID of the message being tipped, and the amount of ether tipped. So there are multiple functions we wrote. So we will be discussing each one of them. So first one is the post message. So this function allows user to post a new message. It takes parameter as content, which is the content of the message. So when a message is posted, it creates a new message struct, initialize it with the sender address, the content, and the current timestamp, and a tips count of 0. The new message is then added to the message array, and finally it emits the message posted event. The next function is tip message. So basically this function allows user to tip a message. It takes a uint 256 parameter message underscore id, so which is the index of the message in the messages array. So the function checks if the message exists, that is like if the message underscore id is less than the length of the messages array, and ensures that the tip amount, which is like message dot value, is greater than 0. So it basically retrieves the message using the provided id, adds the tip amount to the tip field of the message, and finally it transfers the tip amount up to the message author. Finally it emits the message tip event. And the last function is like get messages. So this function simply returns the entire array of messages, which allows user to view all messages posted on the board. So overall, the message board contract provides a platform for user to share messages and financially support each other through tips. User can simply post messages, view all messages, and tip author of messages they appreciate. The use of event allows for tracking of actions on the blockchain, making it easier for front-end application to listen and change the updates. So now we will be writing the script and the config file required. So we will be simply updating this config file. So we will be simply updating the network to rootstock testnet, also passing the chain ID. Now we will be creating a folder called scripts. Into script, we will be creating a new file as deploy.js. Here we will be adding hard message board, which will get the contract factory, and this message board await message board.deploy, which will be deploying the message board. Now we will simply write the await, which will be like waiting for the deployment. Wait for deployment. Now we will get the address. Wait message board dot get address. Now we will be simply log in the address. Now we will be simply catching the error, if any. I guess the terminal is not working over here, so we will be again opening the folder. I guess it's still not working. Let's use VS Code. So now we will be deploying the contract that we wrote. The command for the same is npx deploy, and the network is stock testnet. So we just need to install .env. So now it's showing compiled one contract file successfully, and it targeted the EVM Paris. It's deploying our contract. Until it gets deployed, we will simply adding our fund. So now you can see the contract has been successfully deployed. So we need to copy the deployed address. Now we will be opening a new terminal. Here we will be creating a new folder where we will be adding our all the front end. So we will be using React over here until we can simply copy our deployed contract address into any file. So let's keep it into readme as of now. So yeah, it's all the packages required for React is now getting installed. You can see the folder client has been successfully created. So it has added the JSON file into which all the node modules are required for React has been installed. So now we just have to modify the code written into the app. Firstly, we will create a folder as constants we can write here. We will be writing as .js, which we will be simply adding the address. Also we will be adding the ABI, which is into artifact contract message. So yeah, we will be simply just copying the array of ABI. So now we will be making the necessary changes into the app.js. So here we will be requiring the use state and use effect. Next we will be requiring Ether, which is from Ether. Next we will be using address, and also we will be using the ABI. Now we will be writing the function app, which is the main function, into which we will be declaring two states. So first would be like messages, and the function to set the messages would be set messages, and the initial value would be an empty array. Next would be the new message, and the function to set the new message would be set new message, and the initial value would be an empty string. Now we will be writing an function that would be an async function. We would be naming it as a request account. We wouldn't be passing any kind of parameters as it's not required over here. Here it would be giving call to the wallet and getting the account request, and to which the method would be it request accounts. Now we would be writing the another function. We would be naming it as fetch messages, and there is no as such parameter we would be needing, so we will be keeping it as an empty. Now we will be checking the type of window dot Ethereum should not be empty, which means there should be at least a wallet to get connected. Now we will be simply adding a const name provider, ethers.providers, which is by a web3 provide, passing window.ethereum into it. Now we will be writing the another constant named as contract. Here we will be passing the address which we have declared into constants. Also we will be passing the ABI and the provider. Now we will be simply writing the try catch block, into which we will be writing the data constant, which will be getting all the messages by simply calling the get messages method which we declared above. Now we will be simply updating the data, and if it fails then we will be simply logging the error. Now we will be writing the another required function, which is the post message. Again here there would be no as such param required, so we will be passing it as empty. Here first we will be writing message as if just go ahead if the new message isn't empty. Now we will be just giving the same checking this, into which we will be awaiting for the method request account. Now we will be simply declaring the const name as provider, which we have done above. We will be simply copy pasting the above code. Now we will be declaring the const as signer, into which we will be calling the method get signer. We simply copying the contract const. Now we will be letting the try catch block. So first we will be declaring the const name as transaction, which will await until the post message gets the new message. Else we will be setting the new message as empty, calling the fetch messages. If this try block fails, then we will be catching the error into the catch block, into which we will be simply logging the error. Now we will be writing the another function, which would be the tip message. Here we will be passing the parameter as message id. We can just copy paste this. Now we will be writing the try catch block, into which we will be declaring the const transaction, which will await and give call to the initiate would be the 0.01. Now we will make it await until the transaction get fulfilled. We will call the fetch messages. If this try block failed, we will be using catch to handle it. Into catch we will be simply logging. Now we will be calling the use effect hook initially to fetch the messages. Also here we will be passing the empty dependency array. Now we will be writing the part that we need to be displayed on the front end. Firstly we will be simply defining a div with class name as app. We will be giving heading as RSK message board. We just simply giving a div, into which we will be writing an input box, which type would be text, value would be new message, and on change it should set the new message. So it would be set new message and the value to be like the one we get from user. So we will be simply writing as e.target.value, and like we can also pass the placeholder as write your message, and we will be simply closing the input box. Now we will be writing a button which on click should call the post message, and like on the button we can display as post message. We can keep this div. Now we will be displaying the message part. So for this we will be declaring a new div. We will be naming the class name as messages. So we will be using a map to get all the messages that we have into the array. Here again we will be writing a div with key equal to index. The class name would be, we will be simply giving it as a head as message.count. Content we can display simply using the small tag into which we can show by and the name of the, now we can display the content into a new line. We can simply declare it as it is a self-closing tag. Now we will be using displaying the tips ethers dot utils dot format ether, and we can simply get it into rbtc. So for to happen the tip to be working, so we can simply create a button which on click the tip message should be getting called, into which we will be simply displaying tip. We can write the value as 0.0 rbtc as also. Now we simply need to export our app by just doing export default app. So like first we need to get into the client folder. Now we need to install the ethers by simply writing the command npm ethers. Now to run the front end we simply have to write npm start. Now like by default it is 3000 port, so now we can check like we got an heading as rsk message board. Now into the input box we have to write the message that we want to send. So let's write as rootstock, hello rootstock. So we will be simply posting this message. So now our metamask got a pop-up. So here we will be using the rootstock testnet as the network, and the network fee here would be like $0.01. So we will be simply confirming the transaction. Now our transaction is been processing. So here we can see like the post message and the transaction is being in pending state. Once it gets success, our message gets added over here. We can also see the status on the block explorer of the rootstock. Still our transaction is in the pending state. So here we can see the state is into the pending state, and all the related details of our contract deployment has been gotten here. So yeah, the message got successfully added over here. So now we can check the status of our transaction has been confirmed. Also we can see here the status has been successful. So just due to that we got our message hello rootstock over added here. Now you can simply tip. So here we don't have like that much fee, so we will be simply canceling this transaction. So while coding, if you face any kind of issues, you can simply go to the doc. So Rootstock has their dedicated AI. So you can simply ask the AI. It answers your all the doubts in real time. And if still you face any kind of issues, just go into Rootstock Discord and ask your question into the respective channel. Thank you everyone. Happy coding.